Friends, in last session we discussed what is simulation, how simulation is defined, what are different advantages of simulation, what are limitations of simulation, then application of simulation. Also we discussed Monte Carlo method and what are different steps to simulate the problem with the help of Monte Carlo methods. So in this lecture, in this session, we will see some problems. So actual simulation by using some methods. So let us see one problem. So read careful one problem. So example 1 we'll see. Customers arrive at a service facility to the required services. The interval and service times are constant and are 1.8 minutes and 4 minutes respectively. Means what? See, one service facility is there. So customers are arriving there. So the interval of arrival is 1.8 minutes. Means first customer is coming at a particular time. After 1.18 minute, second customer will arrive there. And third customer will arrive again 1.8 minutes interval. Okay, so the interval of customer is 1.8 and the service time means the time required to provide them service is 4 minutes. Then simulate the system for 14 minutes. Now our question, our motto is to simulate this system for 14 minutes. After 14 minutes we will not simulate this, but for first 14 minutes we have to simulate. Determine the average waiting time for a customer and ideal time for the service facility. So let go to the solution. Note down. The arrival time for customers within 14 minutes period will be. So write down here customer. So there are n number of customers. Let some customers 1, 2, 3, 4, 5, 6, 7, 8 customers. It is not given in a system. In a question it is not given how many customers are arriving there, but it is told that it is given that the arrival time. Let first customer is coming, you write down the time is 0. You write down time is 0. That first customer at 0 time, 0 interval. Okay, he is. So your time starts with first customer. So it is 0. Arrival time of first customer is 0. Then second customer, the interval is 1.8. Then third customer plus 1.8, that is 3.6 minutes from initial. Then plus 1.8, 5.4 plus 1.8 plus 1.8 plus 1.8 plus 1.8. In this way, so the 8th customer will arrive here is 12.6. What about 9th customer? So 12.6 plus 1.8, it exceeds 14 minutes. So you consider only 8 customers. So as simulation is required for only 14 minutes. So here 9 customer, so 12.6 plus 1.8, so 13.6 and 14.4. So it exceeds 14 minutes. So you need not to consider 9th customer. So you will simulate for only 8 customers. We'll simulate it for only 8 customers. The time at which the service begins and ends within the time period of 14 minutes is shown. So here now it is shown below. Okay, you write down the customers and begins and ends and waiting time. But for in 14 minutes you cannot satisfy all these 8 customers. These are arrived customers, but the service ends, starts and ending. So it is different for different customers, as the service time is 4 minutes. So waiting time for customers and idle time for service facilities are also calculated. So let us see the customer 1. First customer, so beginning time is 0, ending time is 4. So waiting time for first customer is 0, and idle time for service facility also 0. Now you consider the second customer. Second customer arrive at 1 minute, but his service begins 4 minutes and ends 8 minutes. So what is the waiting time for customer 2? So he arrived at 1.8, but begins at 4. So 4 minus 1.8 is 2.2. 2.2 minutes is a waiting time. And ideal time for service facility is 0. Similarly for third customer, so third customer arrival time is 3.6. Whatever will be the service time, but his service begins after customer 2. Okay, so that 8, it begins at 8, ends at 12, and waiting time for customer 3 is, so its service begins 8 and arriving time 3.6, that is 4.4 is the waiting time for customer. And ideal time for service facility is 0. Similarly for customer 4, the beginning time is 12. When the customer service for customer 3 is over, then service for customer 4 begins, that is 12. So what is service time? 4 minutes. So 12 plus 4, that is 16 minutes. Then what is waiting time for customer 4? For customer 4, waiting time is 12. So it is the beginning time of customer 4 is 12, and arrival time of customer 5.4. So 6.6 is the waiting period, and the ideal time service facility. So this is about first 4 customers. What about remaining customers? So waiting time for first 4 customers is calculated above. So which can be started and which can be completed. But once 4th customer, okay, so it exceeds 14 minutes. For the remaining, it is calculated below. It can be calculated below. So only waiting time you can calculate, but you cannot calculate the service, as we cannot give service them. So means at this stage, so service starts and begin we cannot calculate, but we can calculate waiting time for remaining. So customer 5, 6, 7, 8. So here, if you consider that 14, so after 14 minutes, if you have opened all your counters and you can satisfy multiple customers, then waiting time for 5th customer. So what is the arrival time of customer 5th? That is 7.2. And what is the beginning time? Let 14 minutes. So 14 minus 7.2 is 6.8. Then 14 minus 9, 5. 14 minus 10.8, 3.2. 14 minus 12.6, 1.4 is the waiting period for next 4 customers. So let us calculate average waiting time of a customer. So you make a sum of all waiting time of customer. So sum divided by number of customers 8. So 3.8 minutes is the waiting time. And if you see the facility, so ideal time of facility is nil. So in this way you can calculate the required thing. So what is asked in question? Determine the average waiting time of a customer and ideal time of a service facility. So in this way you can calculate. Okay, let us move to next problem. Let us discuss second example. A bakery keeps stock of popular brand of cake. Daily demand based on past experience is given. So daily demand is given. So it is 0, 1.5, means it is 15, 25, 35, 45 and 50. And the probability means this is demand. So it exists 0 to 50. Demand, it may be vary day to day. And its probability. So 0 probability is very less. Also her highest demand is also very less, 50. So it is a probability. Means it is a number of it is a repetition, you can say, the demand. So the maximum probability is of 35. So this is given. Consider the following sequence of random numbers. So these are random numbers. These are sequence of random numbers. So for 10 demands, for different demands, these are random numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Using the sequence, simulate the demand for next 10 days. Find the stock situation if the owner of bakery decides to make 35 cakes every day. Also estimate the daily average demand for cakes on the basis of simulated data. Okay, means you have to solve this problem in 3 steps. First, using the sequence, simulate the demand for next 10 days. You have to find out, you have to decide demand for next 10 days. Then second, find the stock situation. If owner is manufacturing every day 35 cakes, then what will be the stock every day? And the last is estimate the daily average demand for cakes on the basis of simulated data. So let us tabulate the given situation. So daily demand, then probability. Simulated demand for cakes for next 10 days can be obtained from the table. So given data demand, you keep in one column. So this is in one column. So this is demand. So 0, 15, 25, 35, 45 and 50. This is variable demand. Probability of each demand. Cumulative probability. You write down cumulative probability means what? See, in first row probability 0.01, so you write as it is. In second row, so probability in second row cell and first row you add. So this is a cumulative probability 0.16. Similarly 0.16 plus 0.20, that is 0.36. Similarly 0.36 plus 0.50 and 0.50, that is 0.86. 0.86 plus 0.12, it is 0.98. 0.98 plus 0.02, it is 1. So this is a cumulative probability and the last will be the 1. It should not exceed 1. Then select random variables. So random numbers, these random numbers should be in between 0 to 99. So see here, it depends again. So here it is 0. So first 1 to 15, then second 15 to 35, and then 36 to 85, and then 86 to 97 and 98 to. So these are random intervals. Now in question it is given random numbers. random numbers. Consider sequence random numbers. This is for one random number. This is for second. This is for third, fourth. Okay, in this way these are random numbers. So you find a fit for this random number in the given table. So you can see the 48. 48 is here it is fitting in this 36 to 85. 36 to 85 it is fitting. Here it is fitting 35 to 86. So in between 36 to 85, so it is, so it's here 48 1. So first and 48. Then what about 78? 70 is also fitting here. 78. Then 09. 09, third sequence number 09, where it fits here 1 to 15, in between 1 to, so third sequence number 09. In this way you fit all random numbers here. Total 10 random numbers are there. So out of that 4 random numbers are fitting at interval of 0 to 15, and remaining 6 random numbers are fitted at random intervals in between 36 to 85. So in this way you can complete this whole table. So one more thing, how to get this random number interval? See here it is 0 beginning. So 0 to 15, 0 to 15, then 16 to the number before this 35, then 36 to number before this, that is 85, then again 86 to number before this 97, and then 98 to number before this is 99. In this way you can fix this random number, and you have fitted this random numbers, given random numbers. In order to simulate the demand, the number 00 is assigned to 0 demand. So number 0, 1 to 15 are assigned to the demand of 15 cakes. 16 to 35 assigned to demand 25 cakes, and so on. The given 10 random numbers are fitted in the last column corresponding to the ranges against the demand values. So these random numbers given demand for cake for next 10 days. The serial number of these random numbers are shown in the parenthesis. So number of cake demand in next 10 days. See, so first day demand is 40, it comes under 35, so it will be 35. Then first day 35, second day 35, third day 15, fourth day 35, fifth day 35, sixth 35, 7th 15, 8th 15, 9th 35, and 10th 15. In this way you can write. So number of cake demands in next 10 days are 35, 35, 15, 35, 35, 35, 15, 15, 35 and 15 respectively. Here 35 means it is fitted in this particular row, and 15 means it is fitted in second row. Okay, with the help of this fitting of that random numbers, we decided the demand in for next 10 days. Okay, so this is a first answer. So use the sequence, simulate the demand for next 10 days. So this is a demand for next 10 days. This is a demand for next 10 days. It's demand for next 10 days. Now next one, what is asked second? Find the stock situation. If the owner of the bakery decides to make 35 cakes every day, if he is producing 35 cakes every day, what will be the stock situation? See, now make a table, day 1 to 10. So demand already we find out. Okay, it is there with us. So write down this demand. Number of cake made, if it is 35, write down 35. See, it is not exceeding demand, but somewhere it exceeding demand. In third day, demand is 15 but number of cakes are 35. So stock is 20. Okay. Here it is stock remains as it is, as 35 consumes. Again on 7 days there is a 20 stock, so it is added. Then again 20 it is added. In 9 day no stock, but it remains same. In last day again 20 added. So total 80 is a stock. It is a stock. So the stock situation for various days, if the decision made to make 35 cakes every day, so this is the stock every day as per demand and production. And the total stock at the end of 10 days will be the 80. If manufacturers make the cake, number of cakes manufactured 35 every day. Okay. And what is third question asked? Also estimate the daily average demand for the cakes on the basis of simulated data. Estimate daily average demand. So daily average demand, how to find out daily average demand? It is a logical one, the daily average demand. So this is the actual demand divided by 10. So this is demand. So sum if and divided by 10. So this is the average. So 27 cakes is the average. If you produce every time 27, sometime it short, sometime it exceeds, and the cumulative, the whole total stock will be the 0, but it should not be advisable. Okay, but average daily demand is 27 cake. Okay, so this is the answer for third question. In this way you can find out, you can simulate the demand for future. Okay, you can find the stock situation. Also you can estimate the daily average data on the basis of simulated data. So these are some applications. In next sessions we will see similar types of problems. If you have any doubt, you can ask. You can drop your comments and questions in chat box. Also you can contact me personally. If any doubts, we will clarify all your doubts. Thank you very much.